This is video 3 of the topic of looking at quadratic inequalities. And as I said at the beginning of the first video, what we're going to do now is revert back or cycle back to looking at a problem that's a quadratic equation, and we are trying to find out the nature, a value of r that will give us these different types of roots. So we're going to find the values of r for which this equation has two distinct roots, one real repeated root and no real roots. And most of the work that we're going to do is going to take place in part A, and once we have our inequality and we set up our sign chart, these two are going to come pretty easily. All right, so when we're looking at the nature of the roots, remember that we're looking at the discriminant. And the discriminant, if you recall, is b squared minus 4ac. It's the expression that's under the square root sign in the quadratic formula. So I need a, b, and c. So a, remember, is the coefficient of x squared, so that's 1. B is going to be the coefficient of x, which is 3r. And then c is the constant term, and that's 1. So the discriminant then is going to be b squared, so 3r squared, quantity 3r squared, minus 4 times a, which is 1, times c, which is 1. So we end up with 9r squared minus 4. Now, if we want two distinct roots, actually this should say two distinct real roots, let's be clear about that, then that means that 9r squared minus 4, the discriminant, has to be greater than 0, right? If this is in the equation negative b plus or minus the square root of b squared minus 4ac, if I want real roots, this cannot be a negative number, so it has to be greater than 0. So notice that what we have here is a quadratic inequality. So if we use the techniques that we just learned, remember the first thing that we want to look at is where is 9r squared minus 4 equal to 0? And we can do this by factoring, because if we want to make a sign chart for this, factoring is the best way to do it. Again, to find the positives and negatives. So notice that this is the difference of two squares. Square root here is 3r, square root here is 2. So this is going to factor as 3r plus 2 times the quantity 3r minus 2 equals 0. And you can check it. If we multiply these first together, we get 9r squared. If I multiply the outers, I get negative 6r. Inners give me positive 6r, so that adds up to 0. And then 2 times negative 2 is negative 4. So that means now if I have the product equal to 0, when I set each of these equal to 0, I'm going to get r is equal to negative 2/3. Or this one will give me r is equal to positive 2/3. I'll let you go through that work. So if I set up the sign chart for this, I want r values here. So I want negative 2/3 and positive 2/3. And remember, we're checking the sign of 3r plus 2 times 3r minus 2. And we know that this is going to be equal to 0 at these two, for those two values. If I want the signs of the different sections, then remember we need to pick test values. I'm going to run into this section, but we don't need much for part B. So test values in this section right here, I'm going to choose negative 1. In this section right here, I'm going to choose 0. That's always a nice, easy one to check. And then in this section over here, I'm going to choose 1. And remember, what we're checking is the sign of our 3r plus 2 times 3r minus 2. And so when I sub in negative 1 in both of these places, I'll get negative 3 plus 2, so that's negative. When I put negative in here, for this one, I'll get negative 3 minus 2, so that's also negative. So that's going to give me positive. When I try 0, subbing that in, I get a positive here, and I get a negative here, so that's going to be negative. So that's negative. When I try 1, I get positive times positive, which is also going to be positive, so that's positive. So it looks like if we want this product to be greater than 0, that we're interested in these two sections. So we need to write what the x values are for that one. So the x values here are, as an inequality, you could write x is less than negative 2/3. Notice I did not include that negative 2/3 because we don't want this to be equal to 0. We want it to be less than, we want the product to be greater than 0. So we don't want to include that endpoint, was my point. Or we can put or x is greater than 2/3. Right? And or is the correct logical operator here. It's either this or it's this. As interval notation, it would be negative infinity to negative 2/3 with the endpoint not included, union 2/3 to infinity. Okay? Now, if we want one real repeated root, remember that means that we want 9r squared minus 4 to equal 0. Well, we've already solved that, haven't we? And we can see it from our chart also, that where that product is equal to 0 is at negative 2/3 and 2/3. So we can just say r equals plus or minus 2/3. And again, you kind of already solved it up here. And then no real roots means that we want 9r squared minus 4 to be less than 0. And we've already done that work. Again, there's the 9r squared minus 4. Where is it less than 0? Well, it's less than 0 right in here. So that's going to be the interval from negative 2/3 to 2/3. So we can say, therefore, negative 2/3 to 2/3. Or as an inequality, it would be negative 2/3 is less than r, which is less than 2/3. And that's the final answer for that part.